This is Mrs. Vaughan. This is the first set of function notes. For our vocab, we have an ordered pair. An ordered pair are the two numbers that identify the location of a point, x and y. The x is the location on the x or horizontal axis, which goes left and right. The y is the location on the y or vertical axis, which goes up and down. So the x will tell you where to go left and right, the y will tell you to go up and down, and then together you can plot a point. A relation is any set of points. So when you look at a graph, if you have a graph with a bunch of points on it, that's called a relation. A function is a special kind of relation. A function is a relation that assigns exactly one value in the range to each value of the domain, which means you can have no repeating x's, which you'll see in the examples on the next page. The domain is the values for the input or the x values of a relation or function, and the range is the possible values of the output or the y values of the relation or the function. Alright, for example, identify the domain and range for each of the following relations and determine whether the relation is a function or not. So the first thing you want to do is identify the domain. The domain we represent with a D and then a squiggly bracket. And we will list all of the x's, so that's -3, 1, 1, and 4. Okay, the range are all of the y values, so 3, 2, 1, and 4. We put an R for that. Okay, we will usually ask you to put these in order from smallest number to biggest number. Okay. Alright, when you find whether it's a function or not, you're only looking at the domain. Okay, in the domain, if there are any numbers that are written more than once that are repeated, these are your repeating x's, this makes it not a function. So in this case, we have repeating ones, so this first example is not a function. If you look at the second example, our domain is 4, 3, 1, 1, and 9. So if you put that in order, you'd have 1, 1, 3, 4, and 9. That's from smallest to biggest. And our range would be all of the y values. So in order, from smallest to biggest, that would be -1, +1, 3, 8, and 8. In order to tell if it's a function or not, you only look at the domain. Again, in the domain, if there are repeaters, then it is not a function. So we have multiple ones here, so this one is also not a function. It's not a function. I don't care if there's repeaters in the range, only the domain. So for number 3, our domain would be 2.3, 3, and 7.2. Our range, in order, would be 5, 5, and 9. In order to tell if it's a function, you only look at the domain. 2.3, 3, and 7.2 has no repeaters, so yes, this is a function. Okay, and that's all you have to do is look at the domain. For number 4, our domain in order is 5, 6, 7, 8, 9, and 10. Those are all the x's or the first numbers. So that's your domain. Your range are all of the other numbers, the y's, the second one. So 6, 7, 8, 9, 10, and 11. If I want to know if this is a function or not, I look at the domain only. 5, 6, 7, 8, 9, 10. None of those numbers are repeating, so yes, this is also a function. Alright, you can also tell if it's, you can look at the domain and range, and if it's a function by something called a mapping. These little bubble pictures are called mappings because you map a number from the first bubble to the second bubble using these arrows. The first bubble have our x's in them, and the second bubble has our y's. which means that our first bubble is also known as our domain, and the second bubble is the range. Okay, so if I'm asking you to identify the domain, for example 1, the domain are all the things in this bubble. So in numerical order, we have -13, 3, 8, and 9. Our range is everything in the second bubble. So I have -4, 4, and 15 in order from biggest to smallest. Okay, now in a mapping it's a little bit harder to tell from the list down here if it's a function or not. What you do is see if there's any repeaters in the domain. So if I look at this first bubble here in red, this is my domain bubble. If I have any number that's pointing, has two arrows pointing away from it, that would be a repeater. 3 is mapping to one number, 8 is going to one number, 13, and 9. So those are all going to one number. So yes, this is a function. Okay, everything is, all the domains are going to one number, none of them are repeating. Example 2, my domain is this bubble. Okay, so I'm going to put this in numerical order. The smallest number is actually -6, then -5, then a half, and 8, and then 11. The range is the second bubble. In numerical order, that would be -5, -1, -1/3, 5, and 9. In order from smallest to biggest, which is a good habit to get into. Alright, if you're going to tell if this is a function or not, you only look at the red bubble, the domain. Okay, if any of these numbers are pointing, have two arrows pointing away from it, it is not a function. If you look at -5 here, -5 is pointing to the -1 and the -1/3. That's a repeater. There are two numbers that the -5 is going to, so this is not a function. Okay, and the repeaters look like this double arrow. Alright, we can also talk about functions and relations in tables. Okay, they don't just have to be written out in a list of numbers, they can be in mappings or also tables. When you look at your tables, the x value is the domain, so that's your first column, and the y value is the range, which is your second column. And that's true on all tables. The first column is your domain or your x's. The second column is your range or your y's. So if I'm asking you to identify the domain, I'm just going to copy down the domain column, which would be 1, 1, and 2 in numerical order. The range in numeric order would be 3, 4, and 5. Alright, is this a function? So go and look at your domain column only, which is this first column, and look for any repeaters. I actually have a 1 here and a 1 here. Also in my list, I have multiple ones, so this is not a function. Not a function. Alright, example 4. The domain is the first column, so in order from smallest to biggest, that would be -5, 1/2, 3, 5, and 8. The range would be the second column, or the y's, which in smallest to biggest order would be 6, 7, 7, 9, and 15. Alright, to tell if it's a function or not, you only look at the domain. And look if there's any repeaters. Now there is a 5 and a -5, okay, but one's positive and one's negative, so that does not count as repeaters. So there's no number written twice here or 3 times, so yes, this is a function. There are no repeaters. Alright, you can also look at relations or functions on graphs. So you want to determine the domain and range and if it's a function or not. The first thing we're going to talk about is actually whether it's a function or not. So to tell if it's a function, you do something called the vertical line test. So you need to write that down. The vertical line test. The vertical line test is exactly what it sounds like. It's a test where you draw vertical lines to see if it's a function. So on this first example, if I draw a vertical line through this graph and I hit it in only one spot, it's a function. So I'm drawing all these vertical lines, but I'm only hitting this blue line in one spot every time I draw a vertical line. So this actually is a function because it passes the vertical line test. Looking at the second example, if I can draw a vertical line through here anywhere and hit the graph in two spots or more, then it is not a function. So this second one is not a function because it fails the vertical line test. Alright, so when we talk about domain and range are, in a graph, is much more visual. You just look at the restrictions. So the domain is the restrictions on going left and right. This first blue line can go left and right forever and ever, so I'm going to say the domain is all real numbers, which means it can go left and right forever and ever. If I look at the range on this line, it can also go up and down forever and ever. So there's nothing to restrict it there, so the domain and range is everything. If you look at this second example though, okay, I have this C looking shape. Okay, this actually has a pretty clear restriction. It actually starts right here and goes to the right forever, which is great, except that it has a restriction. It's not going left and right forever. So when we look at the domain is actually going to be an x, and the x is going to have to be bigger or equal to -5, which we just did inequalities, so that should make sense. The range is going to get bigger and bigger up and down forever and ever. There's no restriction there, so this is all real numbers. Alright, in these examples I'm going to start with the vertical line test. So if I draw a vertical line on this first graph, I'm not going to touch it in two places, so this is a function. Okay, if I look at this second example, if I draw vertical lines on this graph, it's also going to pass the vertical line test, so this one is a function. Okay? Now when we go back and talk about domain and range, the domain is going to be left and right. Are there any restrictions there? Well, this first graph that looks like a U is going to get bigger, wider, left and right forever and ever. So this is all real numbers. There's no restriction there. There is a restriction on the range though. The graph starts here at 0 and goes up. There's no down though. So the Y has to start at 0, okay, and get bigger. So that's going to be greater than or equal to 0. The domain on this second function, it's actually going to go left and right forever, so that's all real numbers. And it's going to go up and down forever, so the range is also all real numbers. There's no restrictions there. Alright, our last example, if you draw a vertical line through here, I can touch this smiley face in a bunch of places. Okay? It fails the vertical line test miserably. Okay, so this is not a function. It's a pretty picture, ha ha ha, but it's not a function. Okay, and when we talk about our domain on this circle is going to start here at the edge of the circle and end here. So this domain actually starts at 1 and ends at 5. X has to be in the middle. Okay, so it's going to be bigger, greater than or equal to 1, but it's going to be less than or equal to 5. For our range, it's going to start here on the axis at 0, and it gets as tall as 4, but that's it. It'll never get any taller. So our Y is between 0 and 4. So again, y will be greater than or equal to 0 and less than or equal to 4. Okay.